Last year, NASA's Deep Space Network, a vast array of space, antennas received a data packet from over 24 billion kilometers from Earth. Nothing too unusual so far. For months, maybe even years, data from that region had been steady, predictable routine signals, nothing more. Those signals came from Voyager 1, the farthest human-made object ever launched, silent messenger crossing the interstellar void since 1977. But on November 6, 2024, everything changed. A new data packet arrived, and with it, a surprise. Voyager 1 had altered its trajectory, ever so slightly but inexplicably. No command had been sent. No correction maneuver recorded. After this subtle deviation, Voyager 1 aimed its instruments toward a region of space that had never been explored before, a sector without any cataloged stars or known astronomical objects. A patch of the cosmos simply empty. Even more intriguing was NASA's silence. No official statements. No explanations. The Jet Propulsion Laboratory only hinted informally that the probe's behavior suggested an act of volition, a voluntary decision, as if Voyager itself had chosen its path. But that makes no sense. The probe has no self-awareness. Its operations are entirely based on 1970s-era programming, powered by a plutonium-fueled thermoelectric generator. Voyager 1 is a relic from a time before Wi-Fi, before the internet, before home computers were common. Its mission logic never expected it to survive beyond the heliopause, the boundary of the solar system, and yet, by some engineering miracle and decades of remote fixes, it still functions. Voyager 1's mission is simple. Keep going, record the unknown, and send data back to Earth. It's meant to observe and report without questioning, without interpreting. Just transmit whatever it encounters. Compared to modern tech, Voyager 1 is practically a museum piece. Its work purely mechanical, its movements precise and predictable. It was never designed for spontaneous decisions, let alone autonomous maneuvers. Yet something changed. It shifted, and not automatically. Around the same time, the probe also recorded a low-frequency hum embedded within its data. At first, scientists thought it was an instrument glitch common in old equipment exposed to deep space for so long. But that noise soon drew more attention. Analysts cross-checked the data across 3 Deep Space Network centers, and what they found was unsettling. The noise repeated in regular intervals, with mathematically precise patterns. It wasn't solar interference, thermal noise, or instrument failure. A researcher at Stanford University described the structure of the sound as a rhythmic signature like space itself, or something in space was singing in code. Most disturbing, the frequency didn't align with any bands typically used for human space communication. Something outside our reach and maybe outside our understanding. Voyager 1 had heard something at the edge of interstellar space, a silent zone between stars where no star's gravity dominates. The probe had detected a signal. It's a region without planets, without satellites, just emptiness. But even that emptiness isn't completely empty. It's filled with tenuous gas, ionized particles, cosmic dust, and faint radiation, a cosmic desert, but not a perfect vacuum. In that environment, any noise should be random, sporadic, incoherent. But Voyager's detection was the opposite, structured, persistent, rhythmic. Then came the most puzzling part. A few days later, Voyager 1 adjusted its sensors, pointing them toward the source of the signal, as if it were. Curious, scientists scrambled to find explanations. Numerous simulations tried to replicate the maneuver. Maybe it was an internal error, but no thruster firing had been authorized by the Deep Space Network. And Voyager's control software has been frozen since the 1980s. It has no operational autonomy. It was built before the concept of artificial intelligence even existed. Faced with the mystery, JPL engineers meticulously reviewed the data collected by the Goldstone antenna in California, and there, something even more bizarre appeared. Within the original frequency distortion was an echo reflection, but not just any echo pattern that perfectly mirrored Voyager's own pulse. The resemblance was so precise that even the most far-fetched hypothesis began to take shape. Something or someone on the other side had heard Voyager's signal and was replicating it, not necessarily as a reply, but as a mirror. As if to say, in silence, I'm here too. It is important to remember that NASA's Voyager probes each carry the famous golden record of phonograph disc with sounds and images of Earth, music, greetings in 55 languages, nature sounds, and instructions for decoding human language. The idea was clear. If one day the probe was found by intelligent life, it would provide a roadmap to understand who we are. As the anomaly gained attention, the scientific community quietly released technical materials, hoping to attract researchers and new interpretations. Some theories dared to suggest that maybe someone out there didn't see Voyager as just a machine, but as a message. The operational logic behind this phenomenon remains inexplicable. Experts turn to the writings of scientists like Carl Sagan, Kip Thorne, and Frank Drake, hoping to find something that might fit, but in vain. No space mission had ever faced something so outside existing astrophysical models. The sequence of events was catalogued carefully. First, Voyager 1 detected an anomalous frequency. Then, the frequency was confirmed to be non-random. Next, Voyager realigned its sensors toward the source. And finally, the echo, the mirror. The final detail that sealed the mystery was the echo's persistence.